Okay, horizontal shifts, again, this is when they move left or right. These are not hard to identify, but figuring out how far left or right it's moved, that's where you're going to have to pay a little bit more closer to the graph. One thing to notice is the asymptote does not change. For horizontal and vertical shifts left or right, that asymptote does not change. So if you're looking at a graph and the asymptote has changed, then you're probably looking at a vertical shift, not a horizontal shift. The way to tell, the easiest way to tell with a horizontal shift is to pay attention to this point right here. And we talked about basic exponential graphs. They go through that point, 0, 1. So what you're going to do then to figure out how far it's changed is look along this y equals 1 line. Wherever y equals 1 is supposed to line up with that point. So when y equals 1, it's this point now, -4, 1. You can tell from the graph, just by looking at it, you can say, oh, it's moved to the left, right? Moved left. But how much has it moved left? Well, it was at 0, now it's at -4, so that means it has moved left 4 spaces. So it's all about that y equals 1 line. Now, this is in the simplest case when the only thing that has happened is it has been moved left or right. When we start putting multiple shifts left and right and stuff in there, it takes a little bit more work. But for right now, that's the key point that you'll look at. So on this one over here, look at y equals 1. Looks like our point for the graph is right there, which is now at 4, 1. And it's moved right. So we would say it has moved or shifted right 4. So how do I identify them? Look let's see, look at the point. Look for the point. Where y equals 1. And that's going to tell you how far it shifted. It's moved left or right. That part's kind of easy to look at and say, okay, look, it's on farther left on the graph than it was. It's farther right on the graph than it was to start. But that point right there is going to tell you how far it's moved. So this tells you how far. And I have the examples up there, 4's in there. So another thing to point out here is what happens to the equation. So this right here is where the change has been made. This right here is where the change has been made. This is up in the power. We call this inside. When it comes to transformations, when I say inside, I'm talking about up in the power. So for the function, the change in the equation happens up in the power. It does not happen out in front like this other one back here. This one happens, you add or subtract the number at the end of the function. I added that in, sorry, I should have went back. When you change the function for vertical shifts up or down, you add or subtract a number, but you do it at the end of the function. This one, it happens up in the power. You're going to add or subtract inside, which is up in the power. Up in the power. That's key right there. This one, you'll hear me use the word outside, right, which means at the end of the function. So try and associate when you hear the word outside. It'll be on your reference sheet too. That I'm talking about at the end of the function, whereas with horizontal shifts, when I say inside, it's talking about up in the power. There is one other thing about this, though, that we need to point out. on this problem right here, I moved left 4, but I added 4 up on the inside. Over here, I moved right, but I subtracted 4. That always seemed backwards to me. If you add something, then doesn't that increase, which on the x-axis means you go to the right? Well, when you subtract something, you go to the left. It's backwards. Anytime you see inside changes. Oops. Always backwards of what you would think. So if you say you added to the equation, then you actually moved it left. If you subtracted, then you actually moved it right. And you're going to hear me it's happening inside. That means it's backwards. You'll hear me say that a few times. Okay, the next one was reflections. We had 2 types of reflections. We had a reflection over the x-axis or over the y-axis. And it's literally like it sounds. If I flip over the x-axis right here, here's my original equation, right? Let's do that in red so you can see the difference. Ish, we all know what a horrible artist I am, but here's the idea, here's the original. And I've literally, it's almost like I painted this red one on, I folded the paper in half at this blue line, and it printed this new function down on the bottom half as its reflection over that piece of paper. So that one's been reflected over the x-axis. So over the x-axis, that's this one right here. This one, if you look at the original, again, the original looks like this-ish, because we know how horrible the drawer I am. If you were to imagine painting this original red graph and then folding it along the y-axis and mashing the paint in, it would end up producing this picture right here just by touching the paint on the other side. So this one is over the y-axis. This one's over the x-axis. Now here's how I remember it. As far as the function goes, the cutting the paper in half is how I do it visually. Think of folding the paper on that axis. But you notice the change up here in the equations was simply this guy right here. And it's a little bitty, but see that little guy up there. So reflections just mean a negative, a change in signs. Where the negative is tells you what axis it's across. So if that negative is out front, which I'm going to call outside, then it's over the x-axis. Whoops. Over the x-axis. If the negative is up in the power in front of x, meaning inside, I don't know what's going on with this thing, but it's getting kind of irritating. Whoa, where'd that come from? Whoa. Oh, somehow it moved. I'm good. I got you. Pen. Then it is over the y-axis. Okay, so vertical shifts, horizontal shifts, and reflections. Those are the main 3 that we're focusing on this time. So comparing these 3 pictures right here. The red is the original, always. The blue is the new one. I look at it, and the first thing I see is, wait, here was the original asymptote. There's the new asymptote. That means I've moved up. And then I look at where the asymptotes are. This is at y equals 0. This is at y equals 2. That means I've gone up 2 spots. Okay, this second one right here, asymptotes are the same, so there's no vertical shift up or down. So I can move across past the vertical shift. This is vertical. when I look at this other one, then I look at this point that goes along the y equals 1 line. I need to zoom in more, but it won't show the whole thing. Let's try it. Let's try zooming in. Oh, there we go. That works. Let me change colors too. So this one right here, there's no change in asymptote. So there's no shift up or down. But this is the point you look at for horizontal left and right. Lost my words. You look along this line, y equals 1. And you say, oh, it crosses the graph there, which is now the point -2, 1. That to me, I look at it, you know what I mean, trained eye and all that, and I know that it has been moved left. And because that point is now, instead of at 0, 0, 1, it's at -2, 1, I know it has moved left 2 spots. It's not that it's moved left -2. That doesn't make sense. If I say I ran -2 miles, that wouldn't make any sense. So when you're describing this shift, you just describe it with a positive number. So this was a horizontal one. Okay, what about this one down here? Looking at this one, and it looks different, right? Here, first of all, is my original asymptote. Here is my new asymptote. Okay, asymptote's changed. It went up by 2. That one's easy. I can say it has made a vertical shift up 2. But it's also been moved. You can kind of see the curvature has been moved to the left. So it's also had a horizontal shift left. But how much? Now, I told you before to look at this line right here where y equals 1, right? And wherever it crossed that line would be how much it shifted left or right. But that line moves with the asymptote. So that line's actually up here now, right? We went up 2 for the asymptotes. So now you're looking at this spot right here. And that tells me that it's been moved left -3. So that point, that 1, 0 or 0, 1 point moving, it only works if that's the only shift that's been made. If there's been a vertical shift, then it's gonna, you're gonna have to look at a different spot. Sorry, let me write that in the same one. Horizontal shift left 3. That's ugly. Who cares? Okay. Let's look at these ones. So this first one right here, obviously the red is the original. Should have probably done it in red. Red is the original again. This new one, this blue one, I look at it and I can see right away that it's been reflected, right? It looks the same, it's just been put on opposite sides. So, okay, where's the middle? Where has it been reflected across? This right here is the y-axis. If I were to fold it along the y-axis with the red paint, would it produce that thing in the blue curve? Yeah. So this one's been a reflection. And then you just say what axis it's over. Over the y-axis. Okay, this one over here. Now, if you look at it, there's the x-axis. If I were to take that graph, fold it along the x-axis, and I had paint over here on my original graph, would that print onto that other side and give me that blue graph? Yeah. So we would say a reflection over the x-axis. Now what about